Imagine looking at the night sky and believing that the countless stars above represent the universe as it truly is. For most of human history, that assumption seemed reasonable. The stars, galaxies, and glowing clouds visible through telescopes appeared to be the main ingredients of the cosmos. As our instruments improved, we simply expected to discover more of the same, more stars, more galaxies, and more distant objects hidden in the darkness. But modern astronomy has revealed something far stranger. The universe is not primarily defined by the things we can see. Instead, visible matter appears to be only a small part of a much larger and more complex cosmic system. Hidden beneath the glowing surface of the cosmos are forces and structures that remain almost entirely invisible, yet they influence everything around us. Today, a new generation of space observatories is helping scientists uncover this hidden reality in unprecedented detail. Rather than focusing on individual planets, stars, or nebulae, these missions are attempting something much more ambitious. Their goal is to map the architecture of the universe itself. The results are transforming our understanding of cosmic evolution. Recent observations have begun revealing enormous structures stretching across billions of light years. Galaxies that once appeared scattered randomly throughout space are now emerging as components of an immense interconnected network. This network is often called the cosmic web. The name is fitting. When astronomers visualize these observations, the universe begins to resemble a gigantic web of filaments and nodes. Vast streams of matter connect galaxy clusters across extraordinary distances, while enormous empty regions known as cosmic voids separate these structures. The scale is almost impossible to comprehend. A single filament can stretch for hundreds of millions of light years. Entire galaxy clusters containing thousands of galaxies exist at the intersections where these filaments meet. Meanwhile, some cosmic voids are so enormous that millions of galaxies could fit inside them. Yet these vast regions contain surprisingly little matter. At first glance, the cosmic web appears beautiful. But to scientists, it is much more than a visual curiosity. It represents evidence of deep physical processes that have been shaping the universe since shortly after the Big Bang. To understand why this matters, it is important to remember a remarkable fact. Everything visible in the universe, every star, every planet, every moon, every cloud of gas, and every living organism, accounts for only a small fraction of the cosmos. The majority exists in forms we cannot directly observe. One of these mysterious components is known as dark matter. Dark matter does not emit light. It does not reflect light. It cannot be photographed in the conventional sense. Yet astronomers know it exists because of its gravitational influence. Galaxies rotate too quickly to be held together by visible matter alone. Clusters of galaxies contain far more mass than telescopes can account for. Light traveling across the universe bends in ways that reveal the presence of enormous concentrations of invisible matter. The evidence appears everywhere. Although dark matter remains unseen, its gravitational effects have become impossible to ignore. Scientists now believe that dark matter acts as a kind of cosmic scaffolding. Long before galaxies fully formed, concentrations of dark matter began gathering under gravity. Ordinary matter eventually followed these invisible structures, collecting along pathways that would later become the cosmic web. In other words, the galaxies we see today may exist where they do because invisible structures guided their formation billions of years ago. This realization completely changes how we picture the universe. Rather than a random distribution of galaxies, the cosmos appears more like an organized system whose visible features emerge from a deeper hidden framework. And that framework is now being mapped with extraordinary precision. By observing billions of distant galaxies, astronomers can detect tiny distortions in their shapes. As light travels through space, Massive concentrations of matter subtly bend its path through a phenomenon known as gravitational lensing. These distortions are incredibly small. Yet when measured across millions or billions of galaxies, they allow scientists to reconstruct the distribution of invisible matter throughout vast regions of space. The resulting maps are unlike anything humanity has ever produced. For the first time, researchers are beginning to visualize the underlying structure that governs the evolution of galaxies across cosmic history. But mapping dark matter is only part of the story. These observations are also helping scientists investigate another profound mystery: dark energy. If dark matter helps hold structures together, dark energy appears to do the opposite. It is believed to be responsible for the accelerating expansion of the universe. This discovery shocked astronomers when it was first confirmed in the late 20th century. For decades, many researchers expected gravity to gradually slow cosmic expansion. Instead, observations revealed that expansion is speeding up. Something is pushing space itself apart. That unknown influence was given the name dark energy. Today, scientists estimate that dark energy may represent the largest component of the universe. Yet its true nature remains one of the greatest unanswered questions in modern physics. Is it a property of space itself? Is it related to quantum physics? Could it change over time? No one knows with certainty. Large-scale cosmic surveys are now providing data that may help answer these questions. By measuring how galaxies are distributed across billions of years of cosmic history, researchers can track how expansion has evolved. Tiny differences in these measurements could reveal whether dark energy has remained constant or behaved differently in the distant past. Even a small deviation from existing models could force scientists to rethink some of the most fundamental assumptions about the universe. At the same time, these observations are revealing surprises about how cosmic structures formed. Some evidence suggests that galaxies and galaxy clusters may have assembled earlier than expected. Certain regions appear more mature than theoretical models predicted for their age. These findings do not necessarily overturn current cosmology. But they do suggest that important details may still be missing from our understanding of how matter evolved after the Big Bang. As the amount of data continues growing, another challenge has emerged. The universe is generating more information than humans can analyze alone. Modern sky surveys contain images and measurements for billions of galaxies. The sheer volume is staggering. As a result, artificial intelligence has become an essential scientific tool. Machine learning systems can search through enormous databases, identify patterns, classify objects, and detect unusual features that might otherwise remain unnoticed. In many cases, these systems can process years of observational data in a fraction of the time required by traditional methods. Astronomy is entering a new era where discoveries increasingly depend on collaboration between human curiosity and computational power. Yet despite all the technology involved, the deeper significance of these observations remains philosophical as much as scientific. The universe is teaching us a humbling lesson. What we see is not necessarily what dominates reality. Stars illuminate the night sky, but invisible matter shapes their distribution. Galaxies fill the cosmos, but unseen forces influence their evolution. Even the expansion of the universe itself appears to be controlled by phenomena we do not fully understand. The visible cosmos may represent only the surface layer of a far deeper reality. Every new map reveals additional structure. Every new observation uncovers new questions. Every improvement in technology expands the boundaries of knowledge while simultaneously exposing how much remains unknown. That is perhaps the most remarkable aspect of modern astronomy. The clearer our picture becomes, the larger the mystery appears. The universe is not growing simpler as we study it. It is becoming richer, more interconnected, and more astonishing than previous generations could have imagined. And somewhere within those immense networks of galaxies, hidden among invisible forces and cosmic structures stretching across billions of light years, lie answers to questions humanity has not yet learned how to ask. For now, we continue mapping the darkness, tracing the hidden architecture of the cosmos, and searching for clues about the forces that govern everything we see. Because every new observation brings us closer to understanding not only the universe around us, but our place within it. And the deeper we look, the more extraordinary that story becomes.